Okay. A polynomial is an expression. And I have to stop right there because a great many of you do not know what that word means. X plus 5 equals 9. That is an equation. Why? Two reasons. One, it has an equal sign. Two, there's an answer. What is the answer to that? 4. Because 9 minus 5 is 4. This has an answer. X plus 5. Does what is in red have an answer? No. Because you don't know what X is. This is an expression. Okay? You cannot solve an expression. You can change the way it looks. That's it. This whole unit is spent changing the way expressions look to be simpler and easier to deal with. Everybody cool? Okay. So a polynomial is an expression made up of a combination of coefficients, variables, and constants. Now you know what all those things are. I'm going to highlight them in 3 different colors. Coefficients, variables, constants. And now I am going to write a polynomial, okay? Everybody cool? Now, where is the constant? The 2. Because it is always 2. Where is the coefficient? 4. 4 is a number like 2, but it's not going to have a final value of 2, is it? Because whatever x is going to change what that 4 will become, yes? And x is the variable. Okay? That makes a polynomial. So let me ask you a few questions. Don't write this down, just use your brain. Is that a polynomial?
Yeah.
Yes, it's a constant. Everybody agree?
Yep.
You know what it is. Okay. Is that a polynomial?
Yeah.
Excellent. Is that a polynomial?
Yeah.
Look again.
No.
Why?
Because the powers.
Because it has an exponent.
Tell me what that means. Well, let me ask you this. Is that a polynomial?
Yeah.
Why?
Because it has a power.
What is this?
You know the
X times x.
Yeah.
What's this?
4 times.
4. How many times?
Don't know.
You have no idea. So this cannot be expressed. So this is not a polynomial. If it happens once in math, how often does it happen?
All the time.
So is this a polynomial?
Yeah.
Yes or no?
Yes.
Is this a polynomial?
No.
No. Everybody good?
Yeah.
Excellent. A monomial. Mono
Is 1.
Mono equals 1. Like those old school guys with the one lens instead of glasses. It's called a monocle. Mono. Yes. Well, now you do. See how much stuff you learn in math class?
You learn something new every day. Did you know that?
They're all the no offense, Moret, but when a bad guy is German, they always have a monocle. See, Moret knows. It's one of those stereotypes. I tried to get one in the 9th grade when I first needed glasses because my left eye still had almost perfect vision, but my right eye was bad, and my mom was like, "I'm not getting you a monocle." And again, pardon me, Moret, I'm not getting you a monocle. You look like a Nazi. Because I had brown hair and I looked very, that's what my mom said. You know what I mean.
She was old school too.
Not old school. That was just her reason for not getting me a monocle. I was livid, of course, because I wanted a monocle.
Did anyone you know?
No.
Okay.
Yes. Then I promptly lost them. and didn't wear any glasses again until grade 11. Yes, I did not need the strap to keep my glasses on. I have always been able to keep my glasses on.
Nice.
Now, my wife lost her glasses surfing once, and then 3 hours later found them in the ocean.
What?
Not washed up on the shore. Everybody on the beach started looking. Nobody could find them. Like 3 hours later, some kids walking along. Hey, does anybody own these glasses? And everybody was still left on the beach from the original search was like, yay! Another story for another day. Mono means one. So a monomial is a single unit polynomial joined by multiplication. So, is that a polynomial?
No.
4.
No. Yeah.
Yeah, it's a single unit.
It's a constant.
Everybody cool?
Mm-hmm.
So that's okay. Is that a polynomial?
Yeah.
Yes.
Why?
Because it's joined by multiplication.
Because it's joined by multiplication. So that's cool.
Yeah.
Is that a monomial?
No.
No.
Look again. Read the instruction.
Yeah.
No.
Yes, it's a single polynomial joined by multiplication. So that's okay.
4 times x times y.
4 times x times y times z. It's going to give me one answer. If I know what x, y, and z are, I've got it. What about this one? Come on. 4x, y, z plus 1. No. That is a binomial. Bi equals 2, like a bicycle. So, that is, a binomial is 2 monomials joined by what? Addition or subtraction. So, is this okay? 4 plus 2x. Yes. 3xy plus 4xz.
Yes.
Yes. 4 plus 3.
No.
Yeah. Maybe.
No.
Yeah. Because 4 was 1. Yeah.
No.
Yeah. Yes. It's a binomial.
No, it's not.
It's not.
Because it's 7.
Oh.
Oh! Because what do we do in math whenever we can? Starts with an S, ends with a Y, has implif in the middle of it.
Simplify.
Simplify. Okay. Now, wait. What about this?
That's a trinomial.
No, that becomes a trinomial because tri equals 3. So a trinomial is 3 monomials. And just like in cubing, we end the special names at 3. There is no quadnomial, quintinomial, sexanomial, septinomial, octanomial. They don't exist. Everything after a trinomial is a polynomial. Okay? Poly is Greek for many. Nomial is Greek for numbers. So polynomial is many numbers. Everybody good? Okay. So all of you should be able to recognize a polynomial. Now, yeah, you did it in grade 9. To death. At least you should have. Degree of polynomial is something new to you. It is not particularly important for any reason except when your polynomials get gigantic, we like to write them in a certain order just to keep it simple. So everybody who looks at your work can say, oh, I see what they're doing, all right? The degree of polynomials is a little bit weird. You find the degree of polynomials by adding the variable exponents in all terms. The degree is the greatest sum. Okay? So, let's try this. 4 is a polynomial.
Yes.
What degree is it?
1.
0, because there's no variables. Everybody cool? That is a degree 0 polynomial. 4x. What degree is that? 1, because x has an exponent of 1. Everybody cool? Okay. 4x squared. What degree is that? 2. 4xy. What degree is that? 2, because the variable is only 1 and 1. 4xy squared. 3. 2 plus 1. 4x squared y squared plus 2y cubed. Read. Adding the variable exponents in all terms, and the degree is the greatest sum.
4.
That's 4, that's 3. So what degree is this? 4. 1 term. Everybody cool? The only reason we have it is for this. We write polynomials in descending degree and descending exponents of x, meaning alphabetical. So, if I had 3x plus 4x squared, that's not how we like to write it. We want to write that as 4x squared plus 3x, because the highest degree goes first. Everybody cool? Now, if I had 4y squared plus 3xy plus 2x squared, that's not the order we would like to write it in. We would write that 2x squared, because x is before y, and then we finish all our x's. 3xy, then we start on our y's. I don't care. But I am forced to show you because future teachers and profs will. Do you understand me? Okay. Now, good. We've got about 10 minutes, and we're going to do one thing, and then you're going to be off the hook. We are not going to actually play with algebra tiles. But we are going to use them because they have a couple of uses. I'm going to remind you of what they are. That is 1, that is negative 1. That is x.
That is negative.
That is negative x. That is x squared. That is negative x squared. Okay? You use these to show this. Now, this symbol right here, 1, is not actually 1. It is a symbol we use to describe how many coffee cups are in my hand. 1, right? We use this symbol. It's just a symbol. If I had 5 coffee cups in my hand, I use a different symbol, right? I use that symbol. It's still only one symbol, but it's representing 5 things. Everybody understand? Okay. So we have these to show in reality what is happening. So, in English, what is that saying? That is saying 5 times x plus 1, correct?
Yeah.
So, if we were going to draw this out concretely, what is actually happening, I have 1x and I have 1, don't I? There's an x and there's a positive 1. And how many of them do I have?
2.
No.
1 each.
5 of them. So I would draw 5 of them. Everybody remember this?
Yeah.
Okay, good. That's how you would do it in grade 3 with very easy numbers. Okay? The way we use it to help us with factoring, which is where we're going next in this unit, is we do a rectangle. Because this is a factor, isn't it? 5 times, so it's a factor. And 5 is multiplying by x plus 1, which is another factor. Now in a rectangle, width times length will give us our area, correct? Width and length are the factors. Area is the product. Everybody understand? So, on one side we have the factors. 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5. On the other side, we have the other factor. X, positive 1. And in the middle, we fill in the product, the answer. There's 1 there, but it stretches out 5. Then there's 1 there. 1 times 1. Stretches out 5, 1, 5, 1, 5, 1, 1. 5 x's, 5 of them, 5x plus 5. Here, grade 3, where we actually just did 5 of what we were multiplying, we still have 1, 2, 3, 4, 5 x's, and 1, 2, 3, 4, 5, positive 5. And you see how we get the same answer. Does everybody understand? If you don't really get this, that's okay, because seeing it algebraically makes it real easy, which you've also seen already. If there was no plus 1 there, how do I write 5 times x? 5x. If there was no x there, how do I write 5 times positive 1?
5.
Plus 5. What does that give us? It gives us the distributive property that we already know from chemistry, Science 10, and from exponent laws. The 5 times the x, the 5 times the 5. The 5 times the 1. Okay? Your teacher might have had a cute little name for that last year. I don't. Just like I don't call you John when your name is Joseph. It has a name. It's the distributive property. That's why I call it that. Okay? And oh look, the next page. That's where we're going to pick it up tomorrow. Now listen to me.